Hello dear students, welcome to part 9 of the topic of amines, wherein we shall be talking about the good behavior of amines as nucleophiles. Nucleophiles means nucleus loving. That means why do amines love to attach themselves to positive centers? That's what we are going to talk about in today's video. Don't forget that you are on the channel Pen and Paper Chemistry, so you should definitely have your pen and notebook with you so that you can take down notes for offline reference. When we discussed the chemical properties, when we started discussing the chemical properties of amines, the first thing that we said was that the nitrogen is blessed to have a lone pair of electrons. Now, because of the presence of this lone pair of electrons, we said it's a proton acceptor, it's an electron donor, and the third point we had said that was that it is nucleophilic in nature, it is nucleus loving. So we say amines behave as good nucleophiles. Hence the title of this is amines as nucleophiles. As we said, nucleophiles. Break it down. Nucleo is nucleus and philes is loving. That means these are nucleus loving species. Now nucleus carries a positive charge. In other words, nucleophiles have an affection for positive centers. Now they will have an affection for positive centers only if they are themselves negatively charged or they have lone pair of electrons on them. And because of these lone pair of electrons, they tend to donate this electron pair either in the form of negative charge or lone pair towards a positive center, and that is why we call them as nucleophiles. Now, what are the reactions where amines behave as nucleophiles? I realize that I am also able to teach better when the charts are there. So here we come back with my favorite flowchart diagram in order to make understanding easy. Nucleophiles, we are going to take the typical example of primary amines, which are easy to understand. Nucleophiles, the amines are able to behave as nucleophiles because of the presence of lone pair of electrons on nitrogen. With the result, what will it do? Let's take the example of amines reacting with alkyl halides. You remember we did this reaction in the preparation as well of amines. Now this is our electron rich center. Remember halogen, electronegative, positive. Now my alkyl group has become positively charged. And our nitrogen boss is very kind and offers the electrons to the alkyl group. Now when it does that, here it has to do away with one of the hydrogen atoms. So what do we have? R, NHR. We can distinguish between the two by putting an R dash over here, and what are we left here is HX. Remember, we formed the secondary amines during this by this reaction. Here what has happened is effectively the hydrogen, one of the hydrogen of the NH2 group has actually been replaced by an alkyl group. Hence these type of reactions are known as alkylation reactions. Yes, so it becomes super easy to understand. Next, if I on the other hand take an acyl group, that means I replace it by an acyl group. So RNH2 and I react it with acetyl chloride, CH3, C double bond O, Cl. Positive center. Here's the lone pair of electrons being offered to the carbon. With the result, we will have RNH C double bond O CH3. So what type of compounds are these? Just look carefully. What do you see? Oh, that's interesting to see. It's an amide. Imagine if there was a hydrogen over here. You would have the compound CH3CONH2. Yes, the functional group is an amide. Now, one of the hydrogen has been replaced by an alkyl group. So, we will have N-alkyl alkanamide. Amide is the functional group and we do not. So, here we have 1 and 2 carbon atoms. So, ethanamide. We shall be doing more of these equations so that you can understand it more clearly. So what you have done over here is you have replaced the hydrogen by an acetyl group. What is that acetyl group? CH3CO group. CH3CO group. Hence the name of these reaction or this type of reaction is acetylation. Interestingly, acetylation can be brought about using acetyl chloride, acetic anhydride or even esters. If you notice in each of these reactions, we are using pyridine as one of the reaction mediums. Now, this pyridine is actually a strong base. And why do I need a strong base? Notice the side product for each of the reactions that we have written. It is hydrogen from here and Cl, HCl. We know that our amines are basic in nature. So the HCl will come and combine with the base to give us a salt, which we don't want. So what do? Is we take a strong base over here to help us get rid of the HCl which is being generated during the course of the reaction. Okay, so what would be benzylation? Yes, a replacement of the hydrogen by a benzoyl group. What is benzoyl group? C6H5CO. So I will take benzoyl chloride over here, hydrogen and chlorine. If you draw the expanded structure C6H5COCl, positive, negative. And the nitrogen likes to donate its electrons to the positive center. So we will have RNHCOC6H5. Oh, how are we going to name this? Isn't it very confusing? Okay, let's try and make it simple. Again, imagine that instead of this alkyl, I just have a hydrogen attached. Meaning to say I have C6H5CONH2. So what is this compound? Yes, this is benzamide. It's the common name accepted by the IUPAC name as system as well. Now, one of the hydrogen on nitrogen is replaced by an alkyl group. Let's say that alkyl group is methyl. So how are we going to name it as? That means on the nitrogen atom, I have methyl as the substituent and benzamide. So I will just have to join the two parts and this becomes N-methyl benzamide. Isn't this easy? Yes. So if you want to understand, what do? Is you first declutter it. You remove the difficult bits. Go from easy to the difficult in order to name the compound. So let us go back to our chart and try to complete the reactions. Oh, look at that, what mess I've made over here. Okay, decluttered it, removed all the drawings that I had done. So what you have to do now is, in order to make the writing of the reactions easy, you've got two hydrogen atoms, remove one of the hydrogen, you either put an alkyl group or you put an acyl group. What will be the acyl group? RCO group. or you put a benzoyl group, that is COC6H5 group, and accordingly name the compound. If you want to make things even simpler, instead of R, let's say we take CH3NH2. So let's start writing the reactions. How would you like? You want to write it with alkyl? Okay, we can do with alkyl. Okay, so the first one for alkylation, RNH2, and here let us put it as R dash. Now will it be NH2? No, it won't be, because one of the hydrogen is being replaced by an alkyl group. So RNH R dash, what is this? It's a 2-degree amine. Don't forget the pyridine, which helps to remove the HCl which is being formed during the course of the reaction. HCl or HX, whatever. Similarly, with acetyl chloride, again remove one of the hydrogen, attach the acyl group, but see carefully where you have to attach it from. RNH CH3CO. Is that correct? No. That will be wrong. Why will it be wrong? RNHCH3C double bond O. Look at the configuration here. Carbon 1, 2, 3 valencies satisfied. Here look at the carbon 1, 2, 3, 4, 5 bonds being formed. Oh, it is breaking all the rules of organic chemistry. So how do we have to write this compound? You start from the amine. So you have here RNH, RNH. Now the chlorine has been done away with. Look at the structure of CH3COCl, CH3COCl, right? So this has gone off. This is our positive center, which will become attached to the electron-rich nitrogen. That is why we said that amines are acting as good nucleophiles. Clear? Okay. Next is acetic anhydride. First of all, why are we calling it as acetic anhydride? Look at the structure. Our acetic acid is CH3COOH. This in the IUPAC name is also called as ethanoic acid. Now from this ethanoic acid or acetic acid, if I bring about its dehydration, I will have an anhydride. Anhydride means from which water has been removed. Remove water molecule, we will have CH3, CO, and joined by the oxygen atom. And this being formed from acetic acid becomes acetic anhydride, or according to the IUPAC system, we can also call it as ethanoic anhydride. So we can bring about acylation or acetylation using acetic anhydride as well, replacement by CH3CO group. So again start with RNH, C double bond O, CH3, and what remains behind is our CH3COOH. Again we need to carry out the reaction in the presence of pyridine, which is a strong base, in order to remove the acid which is being formed during the course of this reaction. I hope you are copying down these notes. As I said earlier, they will come in very, very handy for offline reference. I will again try to reduce the number of unnecessary structures which we have used only to explain. And I hope you can name this compound now. Yes, again, it's N-alkyl ethanamide. Look at the structure here again. 1, 2. If this was a hydrogen, then this would have been ethanamide. If you look at it in its condensed form, it will be CH3CONH2. This is the functional group, and the total number of carbon atoms over here is 2, hence ethanamide. But what we've got over here is we've got an alkyl group. That alkyl group can be methyl, ethyl, propyl, and so on, and it is attached to nitrogen. So we will put over here N-alkyl ethanamide. E has to become small, and this becomes our compound N-alkyl. So alkyl, instead of alkyl, it could be, as I said, methyl, ethyl, propyl, whatever. Try writing the reaction with an ester, that is an amine when reacted with an ester. Again, look at where the structure is going to be, how it is going to be, what will be the positive center, CH3, C double bond OO, C2H5. Again, a negative, positive. So that means this will break off from here, and amine. Again, connect over here. We will have ditto same structure that we formed in the above reaction. Isn't it easy to understand now? Yes, with the chart I am also finding it so much easier to teach. Otherwise my brain was getting cluttered. Okay. Benzylation, benzoyl group, replacement by C6H5CO group. So how do I bring about benzylation? Using benzoyl chloride, acetylation, acetyl chloride, benzylation, benzoyl chloride. Again, look at the structure, C6H5, C double bond OCl. Take away the electrons, negative, positive. So we will have the structure RNHCOC6H5. Did we name it already? Did you name it already? Imagine that our original compound was C6H5CONH2. What compound is this? Again, benzamide. And you have replaced the hydrogen by an alkyl, so N-alkyl benzamide. So we have written the reactions, or we've discussed each one of these twice. It's a good practice for all of us. So go ahead and write these structures and write the reactions for better clarity on the topic. Okay, now I am sharing each of the individual reactions. Go ahead, try writing these, or try completing these reactions, and try writing the names of the products as well as you continue to write these reactions. Go ahead, try it. I will leave this screen for you. So this we are talking about alkylation. Yes, amines as nucleophiles due to the presence of lone pair of electrons. Yes, even aryl amines can behave as nucleophiles. Please understand over here that we are not talking about this bond being broken. We are not talking about nucleophilic substitution. We are not saying that NH2 group is being replaced by some other atom or group. What we are saying over here is that because of the lone pair of electrons, the amines themselves are behaving as good nucleophiles and replacing other atoms or groups or other weaker nucleophiles. So amines as nucleophiles. Alkylation, replacement by alkyl group. Now complete the reaction of ethanamine. How do we name this compound? In case you have any doubt regarding the naming of amines, there is a separate video on the IUPAC nomenclature of amines. That is how we have reached on to video number 9. We've already spoken about what are amines, we've spoken about their structure, the hybridization, we've also spoken about the carbon-nitrogen bond length, their nomenclature, and we've had quite a few practice as well. We've also covered preparation of amines. So in case you have missed out on any of those videos, please go back and go step by step, and the topic will be fully clear to you. After completing the reaction, try naming the products as well. So here you're going to form C2H5NHCH3. So here it is my longer chain which takes the name of the parent hydrocarbon 1 and 2. So I'm going to name it as N-methyl ethanamine. It's a secondary amine. Look at the functional group NH. Same way, go ahead and name the product formed here, C6H5NHCH3. N-methyl benzenamine or aniline, both are accepted names of the parent compound. Acylation or acetylation, replacement by CH3CO group. Okay, I've taught you the nomenclature. Now tell me, here we are going to form the amide. In other words, we do have, so C6H5 C double bond O. Am I writing it correctly? No. Where did I go wrong? No, the C double bond O group is not getting attached to the benzene ring. It is N and a hydrogen and the C double bond O CH3. Now if you notice over here, my oxygen is electronegative. It pulls the electrons towards itself and forcing nitrogen to share its electrons with the carbon. In turn, we have the resonance phenomena here that you can see. In other words, now my electrons on the nitrogen are no longer available readily to bring about nucleophilic substitution. So that is why the reaction actually stops at this stage. Again, the sets of reactions, please go ahead, complete these reactions with acetic anhydride CH3CO. What do you have to do? CH3COOH and then join the rest of the molecule. Again, CH3CO, CH3COO. Okay, complete the reaction, name the compound. Reaction with esters, again, it's a repeat. Go ahead, complete the reactions yourself in order to gain confidence. Remember where the positive charge is going to be. Where is the positive end? Are you writing? Are you completing the reactions? Are you being honest with yourself? Because you are here to learn. Okay, benzylation, a replacement of hydrogen of the amines by a benzoyl group. Again, HCl and the benzoyl group becomes attached, RNH, C double bond O, C6H5, derivatives of benzamide. Doesn't this make it very easy? Now tertiary amines show the exceptional behavior that they do not react with any of the acid derivatives because simply they don't have the hydrogen. Our tertiary amine would be something like CH3 whole thrice n. So it does have the lone pair of electrons, but there is no hydrogen over here. So that is why they do not show these reactions. I shall also be sharing these notes on the site Pen and Paper Chemistry Google site. Yes, Google site. You can take advantage and you can check your notes as well on that. There are many more topics in physical, organic and inorganic. In fact, your D and F block elements a real trouble for many students, and sometimes it's so difficult to comprehend that topic. Everything is covered on the channel, as well as there are notes on the site Pen and Paper Chemistry. When you Google, it will bring you to the YouTube channel and this site. You can take advantage of it. All is for free. Knowledge is free. Enjoy learning.